Welcome to Vision Plus and welcome back to this S.4 Mathematics. We are looking at stationary points or turning points of a curve. Example 2 says, Part A, identify the stationary or the turning points of the curve given by y equals to x cubed minus 12x and distinguish between them. So we need to first find the turning points of the curve and then we distinguish. Distinguishing in this case means you need to tell whether it is a maximum point, a minimum point, or a point of inflection. So for us to do that, we need the gradient function of the curve. Therefore, we differentiate the equation of the curve, giving us dy dx becomes 3x squared minus 12. Okay, this is the gradient function of the curve. What do we know? We know that at any turning point on a curve, dy dx is 0. That means at a turning point or at any turning point or a stationary point, dy dx is 0. That means since we are looking for stationary points, we shall equate dy dx to 0. So you can substitute either here or you equate to 0. So dy dx is 0. So here we shall have 0 equals to 3x squared minus 12. Then you make x the subject. If I take 4 of this side, it becomes positive. So I'm saying that x squared equals to 4. Then we take the square root. So x equals to plus or minus 2. Therefore, the two values of x are x equals to 2 and also x equals to negative 2. What does it mean when you have two values of x? If you have two values of x, it implies that there are two turning points of that curve that we have. So after getting the values of x, that means that there are two turning points. Then it means that there is one turning point when x is 2, there's another turning point when x is negative 2. And because the turning point is a coordinate point, we need to get the corresponding values of y. So if x is 2, what is the corresponding value of y so that we have a coordinate point? So we substitute for x in the equation of the curve. So y becomes x cubed. The x is 2 cubed minus 12 times x, which is 2. That is 8 minus 24. 2 power 3 is 8 minus 12 times 2. Negative 16. Negative 16. So 1 point is 2 and negative 16. This is one turning point, which we don't know yet whether it is a maximum point, whether it is a point of inflection, or it is a minimum point. Now let us get the other point when x is negative 2. So if x is negative 2, what is the coordinate? What is the corresponding value of y? So y becomes x is negative 2 power 3. We simply substitute for x here as negative 2 minus 12 times negative 2. Yes, this is the equation we are using. Yes. Then we negative 2 power 3. Negative 8 plus 24 plus 24. So I'm getting positive 16. So the other point, the other turning point is negative 2 and 16. This is the other turning point. So now we have two turning points, but we still don't know whether the first point is a minimum point, maximum, or point of inflection. Even the second point, we don't know whether it is a minimum point, a maximum point, or a point of inflection. So we need to distinguish. How do we distinguish between the stationary points of the curve? To get the second derivative, there is another method, but I'm not using that method. The second derivative is where we get d squared y dx squared. How do we get the second derivative? You come back and differentiate again the gradient function of the curve. So this is the gradient function. The y dx is 3x squared minus 12. We differentiate this function for the second time so that we get the second derivative. That gives us d squared y dx squared equals 2. We differentiate this second derivative again. That gives us here 6x minus 0 because 12 is a constant. If you differentiate a constant, you get 0. Now, after getting the second derivative, then we use the second derivative to test for the first point and the second point. So for the first point, which is here 2 and negative 6 and negative 16. I'm going to test for the second point this side. Second point is negative 2 and 16. Let me partition this. But in your working, you can test up, then you continue and test for the next point, but I don't have space. Now, to test for this point, we use the second derivative. Even to test for this point, we still use the second derivative. So we know that this is x, this is y. So we say d squared y, dx squared equals 2. Here where we find x, we put the corresponding value of x in a point. So that there we'll have 6. And in this case, my x is 2. 6 times 2 is 12. After getting your value in the second derivative, then you test. Is this value more than 0? Is it equal to 0 or it is less than 0? Okay? Positive 12 is more than 0. That is what we know. Positive 12 is less than 0. And we say that if the second derivative is more than 0, okay? It is more than 0. If the second derivative is more than 0, it means the point is the minimum turning point. If the second derivative, d squared y dx squared, is more than 0, like in this case, we said it is a minimum turning point. Therefore, we can conclude that this point, the point 2 and negative 16, is a minimum turning point. In some books, they say it is a point of minima. It is a point of minima, but it's the same as the minimum turning point. After testing for the first point, let us come back to test for the second point. Instead, we are testing the second point relative to the second derivative. This is x, this is y. So d squared y, dx squared becomes, substitute for x here. Our x here is negative 2. So we shall have 6 times negative 2. What is 6 times negative 2? It is negative 12. When we judge, is negative 12 more than 0? Is it equal to 0 or it is less than 0? Any negative number is less than 0. So negative 12 is less than 0. And we say that if the second derivative d squared y dx squared is less than 0, what did we say? It means that it is the maximum turning point. If the second derivative after substituting for x is less than 0, it means it is the maximum turning point. Therefore, this point here, that is negative 2 and 16, is a maximum turning point.